our first topic for Module 3, and this is your introduction to three-dimensional geometry. In this particular lesson, we will be looking into plotting points in space, determining distance between points, locating midpoint of a line segment, as well as point of division of a line segment, so that at the end of this lesson you should be able to plot a point in three-dimensional system, determine the distance between any 2 points in space, as well as to locate the point of division of a line segment in space. Recall that into a dimensional coordinate system, we would be using an ordered pair of numbers xy to position a point on a plane, determining the distance of the point from the y as well as from the x-axis. Okay, first we take a look at the three-dimensional coordinate system, and that in this particular system we will be working with 3 coordinate axes, the x, y, and the z axis, intersecting one another at a common point, which is the origin, and these 3 are said to be mutually perpendicular to one another. Okay, so a plane that is to contain the x and the y axis is referred to as the xy plane. The one that contains the x and the z axis is the xz plane, and the yz plane is the plane that would contain the y and the z axis. So the coordinate axis would be, or the coordinate planes would be dividing the space into 8 regions that we call octants. Okay, and that if we are to locate a point in space, we need to have an ordered triple of numbers that would give us the coordinates of the point. The first number, which is the x coordinate, would give us the distance of the point from the yz plane, and then the second number, which is the y coordinate, would give us the distance of the point from the xz plane, and the third number, which is z, would give us the distance of the point from the xy plane. So the coordinates of a point in space would be given in terms of the ordered triple of numbers x, y, z. Okay, now, so here we have the representation of the coordinate planes, coordinate axes in 3 dimensions. So we have the x-axis, the y-axis, and the z-axis, and by convention these are the direction of the positive direction of the axis. So the plane that contains the xz axis is the xz plane. That which contains the xy axis would be the xy plane, and the yz plane is the plane that would be containing y and z axis. So you can view this as a 3-dimensional figure, and the coordinate planes as well as the coordinate axes are mutually perpendicular to one another at the common point, which is the origin. Okay, so in plotting a point in space, we would be needing 3 numbers in the order of x, y, and z, and that we will be plotting the points using this reference for the coordinate axis. Okay, so for example, we are asked to plot the following points using the 3-dimensional coordinate system. So we have point 1, the point 3, 0, 0. We have another point given by the coordinate 0, 3, 0. Then we have a 0, 0, 3, 1.5, negative 1, 2, 0, 2, negative 2, 2, 2.53. So how do we locate them in space? Then we work on it this way. So we have the coordinate axis. So this is the x-axis, the y-axis, and the z-axis. Again, this is the direction of positive x, positive y, and positive z. So to plot the point 3, 0, 0, we start with interpreting this value 3, which is the x coordinate, will tell you the distance of the point from the yz plane. So starting from the origin, what you do is move 3 units towards the positive direction of x. So 1, 2, 3, you hit this point. Now because the y and the z coordinates are both equal to 0, then the point we are looking for is 1, that is 3 units from the yz plane, but would be 0 unit from the xz as well as from the xy plane. So that point will just be a point that will be lying on the positive x-axis. As to the point 0, 3, 0, again, starting from the origin, since the x coordinate is 0, then there is no movement in the x direction. But since the y coordinate is 3, then we will be moving 3 units in the positive y direction. So we have 1, 2, 3, and hit this point. And because z is 0, it means the point would be a point that will be lying on the xy plane. Okay. Now, what about if we want to plot the point 1.5, negative 1, 2? So, starting from the origin, considering the x coordinate of 1.5, what we do is move 1.5 units in the positive x direction. So, we will be at this particular position. And then, with y equal to negative 1, we have to move 1 unit in the direction of negative y. So, that will be going to the right. So, from this point, move 1 unit to the left, and hit this point. This point now will have x coordinate of 1.5 and y coordinates of negative 1. But for number 4 point, the z coordinate is 2. So what do we need to do now is from this position, we move 2 units upward and hit this point. This point now is the point with coordinates 1.5, negative 1, and 2. So you can practice, you may practice with the others. With the other examples there. As to how to determine the distance between 2 points in space, or determining the point of division of a line segment or the midpoint of a line segment, please take note that the formula that are presented here are very similar to those that we have seen for determining distance of points that will be lying on a plane, or determining the midpoint of a segment that is on the plane. Okay, the only difference is that there's an inclusion of a z component here. So for distance, we have this particular formula. In locating the point of division of a line segment in space, then we have these relationships. Again, take note of a consideration for the z component. And then for the midpoint, okay, very similar to what we had in plane geometry. It's just that, again, we have a z component given here. Okay, for some examples, let us determine the distance from the origin 0, 0, 0 to the point B with coordinates 2, 3, 5. So using the distance formula as given earlier, we can pick on any one of these points as our base of 1 with coordinates x1, y1, z1, and the other would be our p2 with coordinates x2, y2, and z2. So picking on the point 2, 3, 5 as our p sub 2 and the origin as p1, then the distance between these 2 points will be as given here, and this will simplify to a 6.16 units. Now that can be illustrated in this particular example. Okay, in number 2, we would like to find the coordinates of point P, X, Y, Z such that P would divide the segment AB in the ratio of AP to AB equal to some ratio R, where A is the point 43, negative 2, and B is the point negative 504 with R equal to 2/3. Again, simply substituting in values in the formula given us to locate the point of division of a segment in space, then we will have this to be x value in terms of x1 plus r times x2 minus x of 1, or we have it equal to 4 plus 2/3 of -9, giving us a -2. Now, using this particular relation for y, where y is equal to y1 plus r of y sub 2 minus y sub 1, r would be, or y would be equal to 1. And again, correspondingly, now z would be equal to 6, and therefore the point of division that would divide the segment AB in the ratio of AP to AB equal to 2/3 would be the point -2, 1, and 2. Okay, summarizing what we had in this particular lesson, simply that a point in space can be positioned by making use of an ordered triple of numbers x, y, and z, and that we make use of the three-dimensional coordinate system to plot the set points, and that the formula for distance between points, the midpoint of a line segment of points on the plane, can be extended to include points in space. It's just that we will have an added component, the third component, involving the z coordinates. Okay, so this is your introduction to three-dimensional geometry. I will see you in the next lesson.